Welcome to math classes. In this video, we'll see some Olympiad preparation problems. Many of them are taken from the AMC, still valid for any Olympiad mathematics Olympiad exam, including IOQM or NMTC or anything. In this video, especially, we'll see the Ptolemy's cyclic quadrilateral theorem. We'll see, understand what is this. Okay, this is the part 14 of the preparation videos. For my complete playlist, please check in my YouTube channel for the Math Olympiad prepared playlist. Yeah, m and n are natural numbers. Let q be the number of pairs. Okay, q be the number of pairs m comma n for which m square plus n square plus 2mn minus 2013m minus 2013n minus 2014 equal to 0. Then what is q minus 2000? Okay, so this problem looks okay. I mean, we cannot understand how to attack it. Look at this. Okay, initial number m square plus n square plus 2mn. When you look at it, you can actually make it m plus n whole square, and then you can take m plus n common here, correct? So you can establish a equation easily. Let's see that. Okay, this is the given equation. Okay, now I can take, I will call this first one as m plus n whole square minus 2013 if I take common m plus n into m plus n, which is equal to 2014. Okay, now from these two I will take m plus n common again. M plus n into m plus n minus 2013 is equal to 2014. Okay, now we know that this m plus n, okay, this m comma n belongs to natural numbers, so they are positives. Okay, and m plus n has to be greater than 2013, otherwise this will become negative, correct? If it is less than 2013, m plus n is less than 2013, this whole expression will become negative, so it cannot be equal, right? So it has to be greater than 2013, and to satisfy this, from observation you can easily tell m plus n has to be 2014. That's the only solution which is possible. Okay, any other value you will start seeing the difference in this product, so you will not get 2014. Okay, so m plus n is 2014, which means if m plus n is 2014, you can have 2013 positive integral solutions, correct? Because you are starting from m equal to 1 to m equal to 2013, and n will go from 2013 down to 1, correct? It will cover all the ordered pairs. Okay, uh, so there are total 2013 solutions. Q is 2013, so q minus 2000 is 13. That's the answer. Okay, next. A, B, C, D, E, F, G, and H are the distinct elements in the set -7, -5, -3, -2, 2, 4, 6, and 13. Okay, these are the 8 and from this set. Okay, but you don't know which one is what. Okay, what is the minimum possible value of a plus b plus c plus d whole square plus e plus f plus g plus h whole square? Okay, so looking at this, we think that this is a 8 variable equation, correct? But this is not a 8 variable equation. This is actually 2 variable equation. This is one, this is other one, and these two also related because sum of these two is sum of these numbers in the set. Okay, so that's what you should strike to you first. So a plus b plus c plus up to h is nothing but sum of all these elements in the set, which is 8. Okay, now if I take a plus b plus c plus d as x, then this will become 8 minus x, correct? E plus f plus g plus h is 8 minus x. So my equation is very simple now. Okay, x square plus 8 minus x whole square should be minimum. This is the minimum value I should get. Now, if you know differentiation, you can easily do this, find out the minimum value of this expression. Otherwise, you have to go with the quadratic equation, right? You have to make it power and then see. Okay, so that's what we'll see now. X square plus 8 minus x whole square equal to 2x square minus 16x plus 64, which I can write it as 2 times x minus 4 whole square plus 32. Okay, now this expression will be minimum only if this is 0, correct? Any other value, this is more than that value, right? When x minus 4 is equal to 0, only then you will get the minimum value of this expression. That means x is equal to 4. Okay, so x is 4, the minimum value is 32. That's the minimum value. Okay, next. The difference between the HCF and LCM of x and 18 is 120. Find the value of x. Okay, so this is simple. Let the HCF be h and LCM be L. Okay, then we know that LCM into HCF is equal to product of numbers. So LH equal to 18x. Okay, and it is given that difference is 120. That means L minus H, always LCM will be more than HCF. So L minus H is equal to 120. Now LH equal to 18x, which implies H is, okay, H, that is HCF has to be one of these factors of 18 only, correct? So it has to be 1, 2, 3, 6, 9, 18. Only these are possible. And LCM, that is L, is multiple of 18. So this is, once you remember this is very simple problem. Okay. LTM should be multiple of 18. H should be one of this one. Okay. Now establish the equation. Okay. Let's do it two methods. First is counting method. Then we will use the remainder theorem to solve it. Okay. The counting method, very simple. You take H equal to, you have so many options, 6 options are there. H equal to 1 if you take, L will be 121. So 121 is not multiple of 18, so ignore it. H equal to 2, okay. L is 122, not multiple, so keep going on. H equal to 6, you get 126. L is, which is multiple of 18, so this is one possible solution. Okay. 9, 18, it's not possible, so which means L is equal to 126 and X is equal to 126 into 6 by 18, which is 42. This is the value of X, other number. Okay. So this is the counting method. For this problem, we should actually choose counting method because you have very small set of factors here actually, which you should check. And you have only one answer. They never mentioned multiple answers. So I think you should stop here actually. So this is easy. Okay. But if you want to just understand through remainder theorem problem, you can do it this way, general method. If it is some other number where factors are very big, then you should go through this method. Okay. So H plus 120 is equal to L. That is what the equation, right? H plus 120 is equal to L, and L is a multiple of 18, correct? Once you know this one, that means this is, I can use remainder theorem, right? H plus 120 is congruent to 0 mod 18, correct? Because this is a multiple of 18. L is multiple of 18, L is nothing but H plus 120, so, right? Now, if I simplify this 120, I can divide with 18 and see what is the remainder. Remainder will be 12. So H plus 12 is congruent to 0 plus mod 18, or if I take 12 to the other side, it will become minus 12. Minus 12 means 6. So H is congruent to 6 mod 18. Now this is the general rule, right? Now I take the set of values in H and see which one satisfies this one. Okay. So out of all this one, only 6 will satisfy. Only H equal to 6 will satisfy this one. Okay. No other thing will satisfy. Okay, so out of these only H equal to 6 will satisfy. So H is congruent to 6 mod 18. So H is 6, which means L is 126, which means X is equal to 42. Okay, so this is a general method. 18 don't satisfy. Okay, 18 is congruent to 0 actually. 6 you will not get. Okay, so I don't think 18 also another solution. 18 is not actually. Okay, no, next. Yeah, this is the interesting problem from AMC. A rectangular box measures ABC, okay, 3 sides. I mean length, breadth, and height. Where ABC are integers, obviously positive integers because it's a these are the lengths, so they will be positive. And 1 greater than or equal to A, greater than or equal to B, greater than or equal to C. Okay, so which means he is already giving a order actually. Okay, ABC you cannot change the order of ABC. Okay, you will only get one order. Okay, now volume and the surface area of the box are numerically equal. How many ordered triples A comma B comma C are possible? Okay, so this is a very interesting problem. You will solve using counting method only, but before going to the counting method, you need to establish some equations, correct? So volume is ABC and total surface area is 2 times AB plus BC plus CA. Okay, now these two are equal, correct? Which means if I divide this, basically it will become AB by ABC plus BC by ABC plus CA by ABC equal to 1 by 2, or 1 by A plus 1 by B plus 1 by C equal to 1 by 2. Okay. Now from this expression, I should establish at least one of the variable, what is the maximum and minimum. Once I know this one, this is very simple problem, counting problem, right? So let's take, we will establish something for A. Okay. Now this expression, we know this is 1 by 2. Obviously, this is more than 1 by A because these are all B and C are positive numbers. So they will have some fractional value increment, correct? So 1 by A is less than 1 by A plus 1 by B plus 1 by C. Okay, which is 1 by 2. So 1 by A is less than 1 by 2, which means A should be greater than 2, or A is greater than or equal to 3. Starts from 3 integral values. So A is greater than or equal to 3. This is one minimum value of A we got. Now let's also check the maximum. The second condition. Okay, maximum condition. A is less than or equal to B, less than or equal to C. So 1 by A is greater than or equal to 1 by B, greater than or equal to 1 by C. Okay, which means 1 by is the maximum number. So 3 by A should be either greater than or equal to 1 by 2. Okay, minimum value of this one will be 1 by 2. Okay, So that means if I take a to other side, then it will become a is less than or equal to 6. This is the maximum value of a. Okay, which means a belongs to one of this one, 3, 4, 5, 6. Only 4 values of a is possible. That's it, because it is integral. Okay, now we can apply our counting method using a values. Okay, only thing is just note down the relation between b and c. Okay, so that is simple. This is the given equation. So ABC minus 2BC equal to 2A into A B plus C, or BC into A minus 2 equal to 2A times B plus C. Just you can actually use same equation, but just to simplification, we are using this one. Okay, so only at one place you will put A and then it is easy. Okay. Now, this equation we will use for each value of A. That's it. And one more thing is, note down this one. A is less than or equal to B, less than or equal to C, which means we cannot have B and C values cannot be flipped. Okay. B has to be less than or equal to C. Okay. So it's a counting problem now. So this is the condition. First case one is A equal to 3. If I take A equal to 3, BC into 3 minus 2, right? That is 1. BC equal to 6 times BC. This is the equation I should satisfy. So build a table. A is 3, B and C. B and you start from B equal to 4 onwards or 3 onwards, you can start actually. You check at B equal to 7, 8, 9, 10 and 12, you get a value, C value, which satisfies this equation. That is 42, 24, 18 and 15 and 12. So there are total 5 entries in this. Okay. For A equal to 3, there are 5 entries possible. Okay. Exactly same way, same equation. You take case A equal to 4. Okay, which means my equation will be 2BC equal to 8 times B plus C, or BC equal to 4 times B plus C. Now here I get 3 entries, A equal to 4, B starts from 5, so 5, 6 and 8. Okay, and you should stop until it is equal, because C cannot be less than B, correct? And similarly, A equal to 5, you get one more set of values, which is 5, and B is 5 and C is 10. Okay, then A equal to 6, you get one more set, which is 6, 6, 6. So total number of solutions, possible solutions is 5 plus 3 plus 1 plus 1, which is 10. These are the 10 variables which are possible for this given conditions. Okay, next. 4 cubes with edge lengths 1, 2, 3 and 4 are stacked as shown. Okay, like this. What is the length of the portion xy contained in the cube with edge length 3? Okay, so which means there is a line drawn from this x here to here, y. Okay, so this is not exactly a diagonal actually. Okay, how it goes is from one side of the smallest cube to the biggest cube other side. Okay, so that means you will form a triangle like this actually. XAY. XA is nothing but 10, because this is 1 plus 2 plus 3 plus 4. XA is 10, but AY is the diagonal of the bottom cube. Okay, now this is my XY. Now, xy is easy. Finding xy is very easy. But what is asking is, this xy goes through this cube, right? Cube 3 it will go. What is that length? In the cube 3, what is the length of xy? That is what is asking. Okay. So, let's see. First find out xy, and then if it strikes how you will get that xy value in 3, before that it's good. Okay. So, let's do that. So, the picture is very clear. Okay. The height is 10. Okay, XA, that is XA is 1 plus 2 plus 3 plus 4, which is 10, and AY is diagonal of bottom square of the side 4, so that is 4 root 2. So my XY is nothing but Pythagoras theorem. If I apply XY, I'll get as 2 square root of 33. Now this much length is passing through from cube 1 to cube 4. Now I need length for 3. Okay, if you think carefully, okay, this is proportional. This length will be proportionally passing through each cube. Okay, depending on their size, correct? So you can consider length as it is the xy is proportional to the length of the cube. Xy length within that cube, okay, xy within cube 3 is proportional to 3, correct? So which means it is 3 times 3 ratios of 3 by 10 ratio of xy, correct? So xy part in cube 3 is 3 by 10, because I'm taking full is 10. So 3 parts is in xy. So 3 by 10 of 2 square root of 33, that is 3 square root of 33 divided by 5. This is the final answer. Okay. Hope you understand the logic here. That's important. Next. Two circles intersect at point A and B. The minor arcs AB measure 30 degrees on one circle and 60 degrees on the other circle. What is the ratio of area of larger circle to the area of the smaller circle? Okay, first see the picture, then you will understand. This is a larger circle, this is a smaller circle. They intersect here A and B points. Okay, AB makes 60 degrees on the smaller circle, 30 degrees on the larger circle. Okay, now all I need is ratios of these circles. Okay, that means capital R square divided by small r square, right? Yeah, let's see. So angle AO1B is 30 degrees, that is here. Angle AO2B is 60 degrees, that is here. Okay, now if you see this is 60 degrees, these two angles are same because both are same sides, radius actually. So this is the equilateral triangle, so AB is equal to small r. Correct? As simple as AB is equal to small r. Now go to the second side. Second side, you can apply the cosine rule. Okay, or alternatively you can use sine rule. This is AB is equal to, that is length of chord is equal to 2 times radius into sine theta by 2. The theta is made here, but I am not using this one because theta is 30 degrees, so theta by 2 is 15 degrees. So you need to remember the sine 15 value, or you have to derive it. Okay, so we'll use this value. Okay, AB square equal to, that is chord square equal to r square plus r square, two sides both are equal anyway in this case, minus 2r square. If it is two different values, then a into b cos 30 degrees. Okay, this is nothing but 2r square minus root 3 r square. Okay, so now this is simple. So ab square is equal to r square, capital R square, if I take common, 2 minus root 3. Now I have my small r. Ab is nothing but small r. So all I need is pi r square by pi r square, capital R square by small r square. Okay, which is nothing but 1 by 2 minus root 3. It's normal. I don't leave third in the denominator. So it will, if you multiply with the conjugate, you will get the value. That is 2 plus root 3 is the answer. Okay, next. For some positive integer n, the number 110 n cube has 110 positive divisors, including 1 and the number 110 n cube. Okay, how many positive integer divisors does the number 81 n to the power of 4 has? Okay, this is one of the very common question, comes in AMC as well as in IOQM also sometimes actually we have seen. Okay, so understand these factors and divisors very well. Okay, this rule, most important rule you should remember. Any integer n can be expressed in the prime factorization as 2 power x, 3 power y, 5 power z, 7 power, all prime factors to the power of something, correct? Then the number of divisors is equal to each power you take and add plus 1. X plus 1 into y plus 1, z plus 1 up to whatever prime factorization has the prime numbers. Okay, so that means example 8 is 2 cube, I can write it. So divisors is 3 plus 1 into nothing is there. So 3 plus 1, that is 4 divisors. What are they? 1, 2, 4 and 8. Okay, so this, once you remember, this problem is simple. 110 I can write it as 2 into 5 into 11 prime factorization. 110 n cube I can write. Okay, n has all this 2, 3, 5, 7, but 2, 5 and 11 will be plus 1 because 110 also there, right? 110 n cube, correct? So n cube will have each one 3 times. Okay, each power 3 times, and 2, 5 and 11 will have 3 times plus 1. So that is 2 to the power of 3a plus 1, 5 to the power of 3b plus 1, 11 to the power of 3c plus 1. Then all other primes to the power of 3 times some power number, d, e, f, whatever. Okay. So now number of prime factors is 110 n cube prime factors is 3a plus 2 into 3b plus 2, 3c plus 2 into 3d plus 1 plus 3e plus 1 and so on. This is all equal to 110. So many prime factors are there, correct? Which is, if I write it as, this is 2 into 5 into 11. Okay, 2 into 5 into 11. So you have to get this 2 into 5 into 11 from this one only, and these three are primes, if you see, correct? So there cannot be any multiples in this. Okay, you have to get only these three values from this one only, primes. Okay, now compare, if you compare, you take 3d plus 1 equal to 2, suppose d will be 2 1 by 3, not possible because these are all integers, d, e, a, b, c, all these are integers. So any of these values with any of this one is not possible because you don't get the integral value. Only possibility is 3a plus 2 equal to either 2 or 5 or 11, doesn't matter, I'm taking 2 here. Okay, so which means a equal to 0. Okay, 3b plus 2 equal to 5 if I take b equal to 1, 3c plus 2 equal to 11 if I take c equal to 3. These are the three values possible. You may ask why you are taking A as 0. It can be other way also. B can be 0, A can be 1, or C can be A can be 3 and C can be 0. Yes, any other combination also possible. I am not interested in the number. What number it forms? I am not interested in this. I am interested in prime factors of 110 n cube, which will be same. Even if I replace these values, the number of prime factors will be same. Correct? So I'll just take A equal to 0, B equal to 1 and C equal to 3. So 110 n cube, I can write it as 2 times because 2 power 1, right? If I take A equal to 0, it is 2 power 1. Okay. And 5 power 4 because B equal to 1. And 11 power 10 because C is 3. And rest all are zeros anyway, so I don't need them. Now from this I can derive what is my n cube. N cube is nothing but 5 cube into 11 to the power of 9, or n is nothing but 5 into 11 to the power of 3. Okay. Now this is very simple. Correct. Now I have my n. All I need is 81 n to the power of 4. 81 n to the power of 4 is 3 to the power of 4 into 5 into 11 cube whole to the power of 4. That is 3 to the power of 4 into 5 to the power of 4 into 11 to the power of 12. So how many factors this will have? Are divisors. Correct. That is 4 plus 1 5 into 4 plus 1 5 into 12 plus 1 13, which is 325. So many number of prime factors, divisors you will have. Next. Yeah, this is an interesting problem. We'll first solve it using algebra and geometry, and then with using trigonometry. Okay, this is where we learn the Ptolemy's cyclic quadrilateral equation. Okay, a quadrilateral is inscribed in a circle of radius 200 root 2. Okay, circle radius is 200 root 2. Three of the sides of the quadrilateral have length 200. What is the length of the fourth side? Okay, so first thing for geometrical problem is draw the picture, right? You draw the geometry correctly, then you will get the solution easily. So this is how it is. Okay, BC, AB and CD are the three sides of the quadrilateral. Okay, AD is the fourth. Okay, AD we are supposed to find because other three are same. Okay, and why you are keeping it only inside half circle? Let's say it is big. Okay, AB is big, BC and AC are like this. Okay, if they are like this, then it will form a perfect square in the circle. Correct. If it is goes out of half circle, it will form a perfect square most of the time. Okay, so only way is it has to be like this. Okay, it is a very big circle. Inside you have three cards of equal size. Okay, like AB, BC, CD, and AD. If you connect, it forms a quadrilateral. This is a cyclical quadrilateral, right? Now, what are the properties which are important? Obviously all three are same size cards, so they will subtend the same angle here at the center, that is theta theta theta. Okay, and these two are exactly same size of the card. So if you join BD and join OC, then this will be perpendicular to each other. Okay, at E it will form a right angle. Okay, this information information we will solve this problem using algebra and geometry. Okay, now geometry part we understood how it is. Okay, now let's go. For simplicity, I'll take each side as L. Okay, and radius as L root 2 because 200 root 2 every time I don't want to write. I want to give a general solution. Okay, if it is L, then the radius is which is OB, OA, OB, OC and OD. Okay, all are basically L root 2. Okay, next. L is 200, obviously. Yeah. Now, OC is perpendicular to BD. We know that. So, triangle CDE, this small triangle, is a right angle triangle. Okay, right angle triangle. So, CE square, this side, not the hypotenuse. CE square equal to hypotenuse square minus other side square. Correct? That is CD square minus ED square. So, CE is equal to square root of CD is nothing but L, and ED is, we don't know the value of ED. Okay, so it is, let's call it X. With this X value is very important, we need to find out this X. Okay, so CE is equal to square root of L square minus X square. Now we'll take another right angle triangle DEO. DEO is another right angle, correct? Or ODE. In this also, if you take OE square is nothing but OD square minus ED square, same Pythagoras theorem I am applying. Okay, so OE is equal to square root of this is L root 2, OD is L root 2, so L root 2 whole square minus DG is X, so X square. So this is also square root of 2L square minus x square. Now we know that CE plus OE is nothing but the radius, correct? Which is OC. So that is L root 2, which is equal to square root of L square minus x square plus square root of 2L square minus x square. Now you have the equation. Use algebra methodology to solve this basically, right? So first thing is square both sides. You will get 2L square equal to L square minus x square plus 2L square minus x square plus 2 square root of product of these two terms. Okay, you take all the terms to one side and square it again. You will get 2x square minus L square whole square equal to 4 times 2L to the power of 4 minus 3 L square x square plus x to the power of 4. Okay, simplify it further. Okay, and then you will get L square equal to 7 L to the power of 4, or x is equal to square root of 7 by 8 L. L is 200 we know. So I actually got the size of ED, which is same as BE. Okay, and BD is 2 times this value, correct? And same as AC also 2 times this one. Okay, now I have 3 sides, 2 diagonal sizes. Okay, only the fourth side is not known, correct? So this is where we apply the Ptolemy's theorem. Okay, who's this Ptolemy? He is back some 2000 years back. He was in Alexandria. He wrote a famous book on mathematics. Even today, those are the basics for mathematics. And this is one theorem which is a basics instead of trigonometry. They used his work actually to solve the problems in those days. Okay, and still we are using Ptolemy's theorem today, right? So what this says is very simple. Okay, most of his theorems are very simple. Some of them are proved, some of them are not proved. Okay, if you are interested in PhD, you can just get hang of that book actually. Okay, what he said is sum of products of opposite sides of quadrilateral is equal to product of diagonals, which means sum of product of opposite sides. AB opposite side is CD, so AB into CD plus BC into AD is equal to product of diagonals AC into BD. Okay, these two diagonals are same, we know that already. Okay, so L square plus L into AD. AD is the only unknown here. Okay, which is equal to AC and BD are same. So 2 DE whole square. Okay, which is nothing but 4 times 7 by 8 L square. Okay, now you simplify this one, whole this one, and find out AD. AD is nothing but 5 by 2 L. L is 200. So 5 by 2 into 200, which is 500. This is the answer. Okay, so I think you understood how to solve this one using algebra and geometry, right? And this is a very important theorem which you should remember for cyclical quadrilateral. Okay, this is only for the cyclical quadrilateral, not for the normal quad. Okay, now same problem we'll solve using the trigonometry and see how easy it is. Okay, same problem. Okay, same. Only thing is you should trigonometry, right? So angle should be there. So I am calling this angle subtended by each chord is theta. So this is theta, theta, theta. So angle AOD is 3 theta, angle BOC is theta, correct? So you know this problem is very simple actually. This is all same information. I'll call each side as L and radius as L root 2. Okay. In BOC, if I apply the angular rule actually, relation of chord BC and radius OB, okay, radius OC, sorry, and angle theta is OC, is nothing but BC is equal to chord length is equal to, which is L, is equal to 2 times R sine theta by 2. 2 times radius, that is BO, sine theta by 2, which is 2 times L root 2 sine theta by 2. From this I can get my sine theta by 2. Sine theta by 2 is equal to 1 by 2 root 2. Okay, this is very simple. Now I have my sine theta by 2. Same thing if I apply actually, chord AD subtends an angle of 3 theta here, correct? Right? So this will become sine 3 theta by 2. And if I can find sine 3 theta by 2, then I got my AD. That's it. Simple. In AOD, AD is equal to 2 L root 2 into sine 3 theta by 2. Correct? Exactly same. Now sine 3 theta by 2 I have to just express in terms of theta by 2. Okay. So that is nothing but sine 3 theta by 2 or sine 3x is equal to 3 sine x minus 4 sine cube x. Okay, just substitute the values, you will get your sine 3 theta by 2 or sine 3x. So AD is equal to 2 root 2 L into 3 by root 2, 2 root 2 minus 4 by 16 root 2, which is simplified, you get 5 by 2 L, that is 500 is the answer. Hope you understand how simple this problem is if you really apply trigonometry. Okay, so you should know, even though you are not introduced to complete trigonometry in 9th and 10th class, you should start learning that. This makes the problems very, very simple. Okay. Hope these are the problems which I want to cover actually in this Olympiad preparation video. Hope you enjoy these problems and continue your mathematics journey. I have my Olympiad preparation playlist and IOQM and NMTC solved previous paper playlist also there. Go through that. All important problems and real question paper problems, they are all right, are there. So you can enjoy your maths, learn maths. Thank you.